I'm Alex Turner. I'm an atmospheric scientist and Miller Fellow at Berkeley. My work is centered on understanding the sources and sinks of greenhouse gases such as CO2 and methane. In particular, my recent work has focused a lot on methane, in part because it's a potent greenhouse gas, so understanding how those sources and sinks of methane may change is really important if we want to know what climate is going to do in the future. However, unlike CO2, methane has exhibited some peculiar trends over the past few decades. We started measuring methane back in the 1980s and saw increasing concentrations throughout the 80s and into the 90s until right around 2000 when it stopped increasing. Then in 2007 it started increasing again, and we don't really know what the causes of these recent trends are, which as a scientist I find absolutely fascinating, and so a lot of my work is really focused on trying to figure out what are the sources and sinks responsible for this. Specifically, my work has shown the importance of changes in chemistry in our atmosphere in these changes we're observing. Now, while there's some uncertainty in these recent trends, it's really important to recognize that the long-term rise in methane is due to humans. There's no debate about that. So it can be clearly seen from the ice core records where we see a dramatic rise in methane that starts right around the period of industrialization. So this sort of highlights two of the main thrusts of my work. The first is understanding what's driving these recent trends we're seeing, and the second is figuring out ways we can mitigate this long-term increase in methane. So for this first question, I primarily use measurements from, say, surface sites, aircraft, satellites, isotope measurements, and interpret them in the context of atmospheric models using a Bayesian inference framework. For the second question, I think methane is an interesting molecule because there's a lot of things we can do to mitigate its emissions. Most of the emissions from humans tend to come from isolated point sources such as oil and gas leaks. And so if you can find those in a timely manner and shut them off, you can make a huge impact on the methane budget. And so I work on developing technologies and methods that can help us find those fugitive leaks. So if you have any questions about my work, feel free to reach out to me through the Miller website, miller.berkeley.edu, and thanks for listening.